Assalamu alaikum everyone, welcome back to my channel. Today we are going to discuss the conceptual question answers of chapter number 8, that is heat and thermodynamics. And in this lecture we are going to discuss the short conceptual questions of this chapter. So let's get started. Moving on to the first question, which is in 60 Fahrenheit walking on a ground weather feels uncomfortable, but swimming in ocean feels very cold. Explain. So the answer is water conduct heat away from the body 25 times faster than air, making 60 degree Fahrenheit water feel much colder than 60 degree Fahrenheit air. In air, insulation and slower heat loss keep you warmer, while in water, rapid heat transfer makes you feel cold quickly. Next question we have question number 2, which is do you think low temperature is only reason for snowfall on the mountains? So the answer is no. Low temperature alone is not the only reason for snowfall on mountains. The key factors include low temperature, essential for freezing moisture into snow. Second is high elevation, air cools as it rises, leading to condensation and precipitation. Third is orographic effect. Most moist air from lower altitude rises, cools, and condenses into snow. Fourth is humidity and moisture. Sufficient water vapors is needed for cloud formation and snowfall. So while low temperature is necessary, moisture and atmospheric conditions also play a crucial role in snowfall on mountains. Next, question number 3 we have, can the temperature of an isolated system changes? Explain. The answer to this question is no, the temperature of an isolated system cannot change because an isolated system do not exchange energy or matter with its surrounding. The definition of isolated system is no heat transfer, no work done or by the system, no mass change, and the second is the first law of thermodynamics. Since energy is heat transfer is zero and the work done is zero, the internal energy remains constant, meaning the temperature also remains unchanged unless internal process like chemical reaction distribute energy within the system. Moving on to the next question we have, as a result of some process, the internal energy of the system is increased. How can one tell that the increase was due to orderly macroscopic work or due to the flow of disorderly macroscopic energy? The answer to this is if the energy increases is due to work, it results from external forces causing organized macroscopic motion, for example compression, stirring, and electrical work. If the increase is due to heat, it comes from rendered macroscopic energy transfer caused by the temperature difference between the system and surrounding. Next question we have question number 5, which is at what temperature in Celsius the volume of a gas at 0 degree Celsius becomes double as its volume while pressure remains constant. So by Charles' law we know that V1 over T1 is equals to V2 over T2. Initial volume, initial temperature, and it's the double volume and the final temperature in Kelvin. Question number 6 we have work done on the system put energy into it. Work done by the system removes energy from that. Give examples. So the first we are going to give examples of the work done on system, that is energy added. The first example is a gas compression. When a piston compresses a gas, external work is done on the system increasing its internal energy. Second is charging a battery. Electrical energy is supplied increasing the battery stored energy. Stirring a liquid, mechanical stirring increases the liquid temperature by doing work on it. And next we are going to give the examples of the work done by the system, that is energy removed. So the first example for this is gas expansion. When a gas expands against a piston, it work done on the surroundings, losing energy. Running a steam engine, the steam expands, pushing the piston and doing work, reducing internal energy, and discharging a battery, the battery supplies energy to the circuit, losing stored energy. Next question we have question number 7. Next question we have, should the internal energy of the system necessarily increase if heat is added to it? So the answer is this, no, adding heat does not always increase the internal energy according to the first law of thermodynamics. If no work is done, internal energy increases. If the system does not work, internal energy may decrease, and during phase change, heat is absorbed without increasing internal energy. Thus, heat addition does not necessarily increase internal energy. Moving on to the next question, that is question number 8. which states that why the slope of adiabatic curve is steeper than the slope of a isothermal curve. So the answer is the adiabatic curve is steeper than the isothermal curve because in an adiabatic process no heat exchange occurs. So pressure drops more sharply with volume expansion. Mathematically, for an isothermal process, PV is equals to constant, and for adiabatic process, PV's gamma is equals to constant, where gamma is greater than 1. Since gamma is greater than 1, the pressure decreases more rapidly in an adiabatic process, making its curve steeper. Next question, we have question number 9, which states that what are the limitations of first law of thermodynamics? So the answer is direction of process. The first law of thermodynamics does not indicate whether a process is possible or not. Cannot fully convert heat to work. It does not explain why heat cannot be completely converted into work. Ignores entropy and irreversibility. It does not account for energy loss due to friction or dissipation. No efficiency information. It does not determine how efficiently energy can be converted. Next question, we have question number 10, which is what are the conditions of isothermal process? So the R, constant temperature. The system's temperature must remain unchanged throughout the process. Next is slow process. The process should be carried out slowly to allow heat exchange and maintain thermal equilibrium. Next is efficient heat exchange. The system must be thermal contact with the heat reservoir to continuously change heat and keep the temperature constant. And the ideal gas behavior, the gas should follow Boyle's law, which is PV is equals to constant, meaning pressure and volume change inversely while temperature remains constant. Next question, we have question number 11, which states that why isothermal processes are slow than the adiabatic processes are fast. So the answer is this is as isothermal processes are slow, temperature must remain constant, requiring continuous heat exchange with the surroundings. To allow this heat transfer, the process must occur slowly, ensuring thermal equilibrium. The adiabatic processes are fast because no heat exchange occurs, meaning the system is thermally isolated. Since there is no time to heat transfer, the process happens rapidly, relying only on the internal energy changes. As a conclusion, we can say that isothermal processes are slow to allow heat exchange and maintain constant temperature. And the adiabatic processes are fast because they occur without the heat exchange, relying only on the internal energy. Next question, we have question number 12, which states that does the entropy increases for the Carnot engine of each cycle? The answer to this is no, the entropy does not increase for the Carnot engine in each cycle. The Carnot cycle is an ideal reversible cycle, meaning there is no net entropy change in one complete cycle. During heat absorption from the hot reservoir, entropy increases. During heat rejection to the cold reservoir, entropy decreases by the same amount. Since the process is reversible, the total entropy change over a full cycle is zero. Next question, we have question number 14, which is why in practical terms efficiency is defined as work done over QH. So the answer to this is efficiency is defined as W over Q because it measures how much of the input heat is converted into useful work. This follows from the first law of thermodynamics and helps assess the performance of heat engines in practical applications. Moving on to the next question, that is question number 15, which is does entropy of the system increases or decreases due to the friction? The answer to this is the entropy of the system increases due to friction, and the friction converts mechanical energy into heat, which increases the system disorder. The heat energy spreads randomly among molecules, increasing entropy. According to the second law of thermodynamics, any irreversible process like friction leads to the increase in entropy. So for today's video, that's it, and we will continue the complete this chapter in the next video. So if you like the video, like, share and subscribe, and we'll see you in the next lecture.